So yeah, hi, welcome everybody. Yeah, it's very nice with the video in front of that. We like that. So welcome to my talk. I'm going to speak about about how to create high-performance web applications with WebAssembly. And first of all, actually, I want to tell you a bit of a story because it's actually kind of funny how it now happens that I'm here and I'm wearing this shirt. Because actually, when I signed up for the Dev Days and to have this talk, actually, I was not working for Flow Traders yet. And what I really would like to tell, because I'm not working as a JavaScript engineer there, and we are still looking for a colleague of mine. And I really loved how they supported me. So because we are now here with a team of 6 people here at the conference, and really did this, yeah, kind of spontaneously. That is very nice. And so it felt very great to have the support. And yeah, so now I'm here, and now I'm speaking as a JavaScript engineer from Flow Traders to you here at the Dev Days. So, but actually, uh, oh, I just turned 27 yesterday, so actually the video isn't accurate anymore. So yeah, so then I guess let's dive into a bit, because so Flow Traders as a financial trading firm has, of course, a lot to deal with performance issues as well. And there's, I don't know, since a couple of years, I guess like the first really stable version appeared last year. There's this new binary programming language, WebAssembly, that's now stabilized in all the browsers. And I want to show you in this talk how actually you can use it for your own purposes, or how you can integrate it in your own JavaScript stack that you maybe have already. So first, let's dive into it a bit. So if you look at the history of it, I mean, of course, yeah. I mean, at first there was like machine assembly. Yeah? So like when you were really coding to the bare metal, and you had this first instruction set. And then, I mean, things evolve, right? So then we had like imperative code. So like statements every time you were not writing directly any bit codes to the processor anymore, but really saying statements, and the machine could understand that. And then things got even better. I mean, we could abstract things, and we could have object orientation. Things started to, become much more usable, much more to the domain oriented, and not this kind of machine oriented anymore. And if you look at new programming languages like Rust, for example, you start to have also patterns and rule systems. You can just like describe really your problem directly in the programming language, and not have to communicate in the language that the machine uses at all. So, and now, okay, this is kind of weird, right? Because now we're going back. So now, does it make sense to go back to assembly? Well, I would like to try to convince you that this does make sense, because let's dive more into that. What is WebAssembly? So WebAssembly is a binary instruction format for a stack-based virtual machine. And it is designed as a portable target for compilation of high-level languages like C, C++, or Rust, enabling deployment on the web for client and server applications. So this is how WebAssembly describes itself on their website. If you dive more into that, so what does that mean? So binary instruction format, and I guess this is like the hugest difference towards JavaScript, for example, is you really don't have like any text elements at all, but you have really binary instructions there. So instead of writing code, you really compile something to the machine. And it also has some nice features, like it is a portable target, so it's not something that has to be implemented or compiled into the browser, but instead you can really serve it like your normal JavaScript files or something like that. And still, a thing that they would like to stress most of the time is it's really for the web. So it shouldn't be, I don't know, it's not basically designed to be used in IoT environments or something like that. there are now, of course, there are now folks out there that do that, and it's also what I will show later. It's also able to use it actually on the server side, but it's basically designed to really be as an extension for your own web application in the browser. So as I said, or as I also point out, that it's a stack-based virtual machine. So maybe I should just shortly dive into that, what that actually means, because what we are used to as software developers is mostly writing imperative code, right? So, but this is not the way that WebAssembly sees the world, but that actually what WebAssembly sees is this. So for example, then all the parameters you have on the one side, you just push them onto the stack, onto the instruction set, and then you just also push the operation itself to that stack, and you get the result then out of that stack. So the processor takes then, when pushing the plus operator, it pops the B and the C argument, does the calculation, and pops B plus C again back to that stack and uses that. And then we can, for example, consume this again to set this to another variable, like with a name A, for example. So, of course, don't freak out yet, because this is not the way that you have to write WebAssembly code. But unfortunately, this is something you have to be aware of when you have, for example, to debug WebAssembly code. And I will show you later on, for example, how to look at WebAssembly code in the browser itself for your own debugging purposes, for example, if you have your own WebAssembly application. But let's more dive into what makes WebAssembly really awesome. So because we have a couple of benefits that are really nice, and yeah, I would like to show you that. So what's first of all, I guess that's a nice thing about every programming language that has this, these benefits, is that it's platform independent. So you can literally use it in any browser, and the support for it is actually very good. So you can already start using that in production, and yeah, I would say like every browser. And there's also the possibility to polyfill it actually. We have near native speed, and this is what really makes this, of course, for this talk very important, because we have the possibility to take bits of the code which tend to be slower in JavaScript, just because you have all this overhead with the way that JavaScript sits in between the processor execution and between the real string processing, something like that. But if you just stay in this WebAssembly world, you have the possibility to kind of directly communicate with the processor of your clients. And this is a very important thing, especially if you are in a mobile environment, because there you can imagine that every kind of JavaScript processing that has to be done on a bad or like on a worse processor you have on your mobile phone, you really want to get just to squeeze out every kind of performance you can. We have interoperability. So this is actually what makes WebAssembly also kind of cool, because so you have a random programming language there being used and not JavaScript. So how do you communicate with that? And there's actually a very nice standard being used in WebAssembly that look kind of like ECMAScript 6 modules to actually add your own values or send your own values to WebAssembly itself and to being executed on the machine there. In the end, what's also very important, especially for the web and also for in terms of performance, you need to have in the end small executables, right? You need to have a small compilation target where you just download a small binary package to your client, to your browser, and don't have to serve like, I don't know. I mean, who of you guys have worked with Angular 2 and Plus and then get 100 megabyte of JavaScript code that needs to be downloaded first, and then the client can start really evaluating the code and can start serving the application. But this is not, the way we want to go, right? So with WebAssembly, we have really the possibility just to be there with only the kind of logic instructions and all the logic parts we just want to serve to our browser, to our users and their browsers. So this is also a very nice feature of it. And yeah, speaking of browser compatibility, how does it look like? So actually, I would say these are is now by now they are all standard. So they're actually all the stable versions of Chrome, for example, is now 74. So this is really has very matured, and also WebAssembly is also going ahead. I will show later on some later features they are going to add, but I can really say confidently you can use this in a production environment. Of course, some guy is here missing. It's Internet Explorer. So yeah, if you want to use WebAssembly modules in Internet Explorer, you have two ways. So for example, you can have for example, a WebAssembly parser that really then translates WebAssembly at runtime to JavaScript. I mean, then the performance, of course, will not be as good, but at least, yeah, Internet Explorers at some point they do have to feel the pain, right? And the other possibility you have is if you have, for example, C as your programming language you want to write WebAssembly in, then you can directly compile that also to ASM.js. And if you have ASM.js, that is 100% compatible with normal JavaScript. And you can directly serve those modules as a fallback to your Internet Explorer users, for example. Or if you really happen to have like a user that has an older browser than those. But also another thing that is very nice is Node.js also supports this now from version 8. So this is also a very a thing you could also really use in your own Node.js environment. And if you do have, for example, like in React application with server-side rendering, where you maybe have some client code process in between, where you already use some WebAssembly, or you want to use WebAssembly for some parts of rendering in the front-end application, and you want to speed that up as well, and now you don't rewrite the whole code for the server side as well, then you can just use really the same WebAssembly code and the same WebAssembly instruction set and use the same APIs also in your Node.js environment. And this is pretty nice. So let's compare the two a bit. Like, okay, what are the main differences between JavaScript and between WebAssembly? And so at first, yeah, I'm going to rate a bit about JavaScript because on the one hand, JavaScript is rather slow to parse and to execute because it's a script language, so you always have to it's easy to write for humans, but it's difficult to parse for machines, so they have to go through every statement, have to create a syntax tree and so on. On the other hand, WebAssembly doesn't have something like that because the binary instruction set really just comes all in this stack-based format directly, each statement after each other. So in every byte is its own statement and has its own meaning. So there's this kind of syntax tree is not required there. Then we have with JavaScript, we tend to have large file sizes. So especially if you have really large applications. I mean, of course, if you can rely on ECMAScript 6 syntax, we can, for example, drop the function keyword and use arrows instead. I mean, there are some ways, of course, to decrease the file size, but in the end, it's never going to be as optimized as really having byte level expressions as in WebAssembly. And another very, I would say bad thing about JavaScript is it's kind of insecure, right? Because if your user, for example, if you don't pay attention to that users really inject some JavaScript code inside the website, and you really not make sure that all the kind of access you have within the JavaScript code is protected, and that everybody just can access that. It can be that you, for example, then at some point use a variable you never introduced yourself, but somebody overwrote with its own code that he has injected. So in WebAssembly, this is really not possible because WebAssembly runs in its own sandbox, and the code cannot be overwritten at some time. There's also some kind of validation in between. So actually, the old code is checked for the whole time, and it's checked that there are some kind of checksums are fulfilled in the end, that there's really no changing of the code possible at some point. So, but of course, yeah, not WebAssembly is not it's not going to bring world peace or anything. So what's on the other hand? So also, of course, this is also a benefit, right, of JavaScript, because you can extend it easily. It's an open world. You can just define, or you can add new libraries easily. You can just add a script tag to your website, and then you have a new global variable, and you can use it, right? So this is not as easy as usable in WebAssembly, because you have to instantiate the module, you have to compile everything first, and you can definitely not bind it to some kind of global variable by itself. Also, JavaScript allows scripting. I mean, if you really just, you want to prototype some application, you want to get started, you just want to write something and you want to make it work, you won't start with WebAssembly first, like, okay, now I'm going to write some C program here and make this super nice, and then I'm going to compile it, and then, yeah, it breaks, it doesn't work. So this is not the way you want to go, right? So it's really nicer to first try to make the application work in JavaScript, prototype it there, and then if you really see like, okay, I have speed limitation here, and I want to make this very fast, then I can add WebAssembly as a benefit and as a performance enabler there. And also, JavaScript is also very easy to debug, right? I mean, you can just open your DevTools in Chrome, and you can set your own breakpoints. You can see where the application logic is running. And especially if you're using source maps or something like that, this makes it also very easy if you have like TypeScript or some other pre-compiled JavaScript code there involved to really, make this work and to make debugging of the code very easy. So unfortunately, the WebAssembly debugging tools, they are not there yet. So they are trying to solve this out, to have source maps, and they're working on that. But as you can imagine, because you have so many source languages, and the bytecode in the end is so unstructured, or is so primitive, so to say, that it's not that easy to map this back, right? Because source maps in the end, they just work like you have a TypeScript code or something else, and you map it to maybe a minified JavaScript code, but still you can see all the control statements there, and you have all the whole structure, or the whole application, how it works. It's still there, and you can just trace it back where everything was. Or this variable now named X was like something like order at first. But it's not that easy in WebAssembly, because variables just can disappear, or functions, they get inlined or removed completely or something like that. So tracing this back is not that easy. So I will later show also how this looks, debugging in the browser, but let's rest here for now. But what I really want you to have as a takeaway is, because, limitation of JavaScript and limitation of WebAssembly, that in the end, they are really a perfect match. Because, if you have low security code, or you have really just, okay, you have a nice React application, and you really just realize, okay, we have some calculations here, and we really realize, okay, the user has to wait for that. Or I don't know, you want to add a game element somewhere. You really have 3D animations or something like that, and you realize, okay, this is slow, and this is not so nice. And we want to improve the performance here, so the user has a better impression of everything. Then you can add WebAssembly to those parts to really make it faster and to make it more awesome for users. And also, what I really would like to see actually, or would like to use more, would also be having this in your own server-side environment as well. So if you can imagine, you have some, your own business logic written in WebAssembly code, and you use it already in the client, that you can maybe also use it on the server side as well for some parts. So for example, if you just have, I don't know, you have some very maybe high secure logic, and you really want to obscure that towards to users, because in JavaScript you can just easily look at the code and maybe trace it back somehow. But with WebAssembly, users are really not that easy, or cannot that easily really look into the code and interpret that, right? So you could use that code then on the client side, but in order not to have the urge to rewrite all that logic again for the server side, you could just use the module there as well. So this would be really a nice pattern that I would like to see in the future being used in setups. So what are some nice use cases we now enable with WebAssembly? And actually what I've seen, I don't know, maybe some of you guys have seen it also, that there are now some websites on the internet, they actually, instead of just serving ads, they also serve Bitcoin miners in the browsers to generate new coins while you are visiting their site. And it's a horrible experience because, you know, you open the website and your processor just, you know, starts to shout at you because it needs to process so much. But it's possible, I guess, or I hope at least. I haven't recognized them lately. I guess at some point they got turned down. But actually, those were written in WebAssembly because, you know, you need high performance code for those parts, and they already use that. Use the very early sets of WebAssembly that were available in Chrome, for example. But you can also think of other high processing things you maybe want to use in your browser. Everything related to machine learning, you want to train something and you yeah, maybe want to offer this as a software as a service to your clients, you could do that with WebAssembly. There's also, if you have some kind of image processing, video processing involved in your application, or games at all, by the way. I mean, if you really want to have a nice 3D game, as you can maybe also play it on your mobile phone or something like that, realizing this just using JavaScript in your browser, it's possible, but it's not as nice. And especially because you have, at first, this overall download time that doesn't make so much fun if your user really has to wait for, I don't know, quarter hour or something like that until the application really is there. So, and because the code size is smaller with WebAssembly, this is very nice. And actually, if you go to webassembly.org, they have an example game over there where you can really directly play in the browser. And the code is, yeah, I guess downloaded within a couple of seconds instead of, yeah, downloading the code in a couple of minutes. And also you can think of, I mean, every kind of application that also needs this kind of limitation when it comes to security. So what I mean here is high security applications is actually that you have where you really must restrict any kind of user that could use just, you know, could fire up like the Google console and then try to hack around with your code. But it is possible if you use WebAssembly, because then it's really limited just to your own environment that you coded there and that you use there. And because you have to explicitly expose code in WebAssembly and to say, okay, this function here, that's public, and I expose that to the browser, and all the other stuff inside here can only be referred to from my WebAssembly code. So if you have really some kind of business logic you want the user not be able to access, then you can use WebAssembly for those parts as well. So okay, then let's dive into some features. What does WebAssembly actually offer us? So here on the left, I put all the yeah, like the primitive types of JavaScript, so to say, or like, yeah, the basic types. And when it comes to numbers, we have actually a pretty good support. So they are just two integer types actually. So the 32-bit and the 64-bit version. It's, yeah, pretty okay, I guess, like standard features. You really have, but you have to distinguish here, right? Because in JavaScript you have only one numeric type for everything, and here you have really to distinguish what kind of numeric type you need or what you want to use. And there are also, of course, floating point numbers. They just have the short name F32 and F64, or again, just relying to the bit size. So now if we take a look at Boolean, we see that, okay, there's not such thing as a Boolean type involved in WebAssembly, but instead we really have to use the smallest and easiest type that is available, and this is actually the integer 32. So now you would maybe like, yeah, okay, but can we have like an 8-bit integer or something like that? But unfortunately it's not there. So if we want to do some Boolean expression, you have to really use an integer 32. But you can also think of maybe using flagging, so you could maybe put a lot of Boolean values just into one 32-bit integer. So then you can improve the space if you really want to, but actually, I mean, memory space is not that important. But now it gets really hard, because if you look at the different, oh, wait, no. So that looks better. Because if you now look at the other types like strings, functions, and objects, you don't have such types at all in WebAssembly. And this is very it makes sense if you understand. I mean, that how strings or functions or objects, how they are processed. I mean, that's really a thing that the outgoing programming language has to support. So like a native, I mean, the processor itself doesn't understand something like a native string, for example. If you have an array of characters, for example, in C, it's still a numeric representation on the processor in the end. So this is also why there is a lag for that in WebAssembly. But if you're using, of course, then C, C++, or Rust, they all have their own string types. You can use those string types then, of course, and they get compiled to those WebAssembly types, so to integers and to floats. So integers, of course, for strings, but yeah, you get the idea. Okay, these are the data types. Let's look at what kind of operations are there. So, and if you now take our operational abacus here, what is there? So, of course, I guess, yeah, we should expect that, and it's of course there. So all the basic arithmetic operations are there. So we can do simple additions, multiplications, division, and so on. Also, if we want to have comparisons, numeric comparisons like greater than, equals, and so on, everything regarding that is also there. So we can use that. If you now look on the bit side, you will find, of course, the shift operations that you can also use in JavaScript, for example. And you find, of course, also the bitwise operators. I guess they are probably mostly forgotten in the JavaScript world that they exist, but they're there also in WebAssembly. And what we don't have in JavaScript actually is also XOR operator, but you can use it in WebAssembly. But one that is actually missing here is the logical, is the binary not operation. So that's missing, it's not there. But there's something else you can use for that instead. Also, when it comes to all those logical operators here, so to if two expressions are true or a not, they're also missing in WebAssembly. But instead, we have the equal zero operation. So, and actually, you can just use this, for example, as a logical not, because if you have an integer 32 and you use it with an equal zero, if it's zero, then this will flip to a 1, and then you know, okay, this was actually false beforehand, and now it's truish value. And it works the other way around as well, right? So if there's like a value of 42 into it, equal 0 is false, so then it will get a 0, and you can use it again. What's also very nice, I guess, yeah, from a personal perspective, you won't use it as much, except when you implement your own hashing algorithm or something like that. The two rotation operators are actually there in WebAssembly, but they're mostly, I don't know, used in the end by the compiler to improve your own code. You know, if they detect some kind of shift statements and all statements, combine them actually to rotation statements, they can just do that. And there's also, the pop count operator, the population count operator that counts all the numbers, all the ones actually within one register. And there's also the trailing 0 and the leading 0 operators, but those are still, I don't know, these are not everyday operators you would ever use, but they're nice to have because they use benefits from the CPU. And if the compiler in the end is able to use those operators to speed up the code, because modern CPU architectures really have those operations implemented on them, then it's really nice because you can squeeze out a little bit of performance there as well. So now I was talking about WebAssembly has matured and is already here for quite some time now. what does this mean with some upcoming features or with things that come that? Because I guess every one of you will now have some kind of expression that this is rather limited, and I would not, like to use this, for example, directly dive into and write some WebAssembly code because there are things missing. I mean, mostly you will need a string at some point and use it anyway. But luckily, there are some things coming. So, for example, just with the current version of Chrome, there are threads now implemented in WebAssembly. So this is another nice performance thing that you can really use parallelized code within your own front-end application. And actually, the overall API that's also there, the Atomics API, I don't know, can you please raise hands if you have heard or ever used the Atomics API in JavaScript? Is somebody who yeah? Okay, I guess you're the only person here, because I guess it's very unpopular at all and hasn't been much used either. So, but instead, it turns out that they are actually somehow pushing for some features to be added to WebAssembly instead to JavaScript, because JavaScript shouldn't be like this kind of power and performance house, but instead should be like just the helpful language to create your front end or to glue everything together. So, and this also happens to the next feature. So actually SIMD support should have been implemented to the overall JavaScript stack, to DOM APIs, but it turns out they actually turned that down and now pushing forward that this feature gets added to WebAssembly. And it makes definitely sense, because if you want to develop your own game and you have really a lot of SIMD operations there, I mean, you really want to do much processing, then it makes more sense really to add this feature to WebAssembly, because you won't ever hardly want to go back from WebAssembly to JavaScript and now start to develop your own game in JavaScript again. And when it comes to the other things, they are actually, I would say, like some features that make it easily or more easy to use for you as a user, especially when it comes, for example, to garbage collection. I would say this is a very nice feature if you want make it just really want make it easier to have object orientation or something like that, because right now, if you would really like to move some Java code or something like that to WebAssembly, you get a huge overhead, because you have to add the whole garbage collection mechanism of Java into your WebAssembly module and to serve that to your user. And in the end, then you serve like 1, 2, 3 megabyte of WebAssembly code in your browser. So you lose the overall benefit of serving small binary bundles to your users there. So in the end, I would say more stuff is coming, and it's going to mature itself even more. For game development, I would say it makes totally sense to now really start trying to develop your own games with WebAssembly and to use it there. But you see, if you want to have to write, for example, a front-end application, like you want to replace React with some WebAssembly-based stuff or so, I wouldn't say it's right there yet, or it's not the right fit for that. Okay, so let's continue and let's go on. So because now we want really to know how can we create our own WebAssembly binaries and use them in our code. And so there's this kind of hello world example. So this is actually how you instantiate your own WebAssembly module. So you have some file like, I don't know, because the Fibonacci numbers to calculate those is very heavy processing, and we really want to increase the performance there by using WebAssembly. And you serve this WebAssembly module at some location from your web server. Then you can fetch that one, create an array buffer, so you get the binary instruction set just out of it. Then you compile the code and or compile all those bytes. You get a module here. So this is then checked actually and verify that the code is valid and that there was no manipulation taking place in between while downloading the code. And then you can create your own WebAssembly instance. And this is very nice because actually the module itself is reusable, so you could imagine just using the code again. And then, yeah, you can use or you can create multiple instances of it if you want to reuse that for purposes later on. And then in the end, you can just simply call the Fibonacci function that is exported out of that instance. So let's see which kind of programming language are supporting that. So there's actually some very good native support by some, I would say, broadly used programming languages like, for example, Go or Kotlin. And there's also, if you're familiar with TypeScript, there are also some folks at, and they call it assembly script, which is basically like TypeScript, but using all the WebAssembly types for it. Then you can also write, code that is very JavaScript alike, but and directly translate it to WebAssembly. On the other hand, and this is what I want to show you as well, is there are like the 4 most mature programming languages that are using that are actually C, Rust, Assembler.js, and the WebAssembly text format. And yeah, if you look at the example, how we could now, for example, really implement the Fibonacci, and we have this C code, we transpile it to our WebAssembly code, then we just have the overall same logic, and then we have an export. Unfortunately, it's prefixed with some kind of underscore. I don't know why, but it's just the way that the C compiler works here. We could do the same, for example, also with Rust. And you can use, for example, those nice pattern expressions here. And Rust actually has its own native compiler for WebAssembly and its own target to create its own WebAssembly module. Yeah, we can just simply use that as well. So, of course, this is very fast. In the end, I will show you the link to the slide, so you can use this for yourself and can look at this later on in the programming language you want to use. There's also the possibility to use JavaScript itself. So if you have Assembler.js, for example, then you add this kind of type annotations here. Yeah, I don't know if I would really recommend writing this by yourself, but if you really just want to write small high-performance bytes in JavaScript, you can use it as that. And compile this with the ASM to WASM compiler that is actually served with the WebAssembly itself. And then you can just, you get the idea, use it with the same glue code. And then this is actually how WebAssembly binary format looks like as a text format. So, and this is where you can actually have, or where you can see the stack-based elements of WebAssembly itself. And you can compile that as well directly to a WebAssembly module, but please don't be so brave and write the code for WebAssembly like that. Even though, because actually, as I promised, this is how it looks like if you want to debug your own WebAssembly code in the browser. So here you can see the Fibonacci function, and you can see that here you're really pushing operations or variables to the stack and performing some kind of here. The LT is a less than operation, which is executed here. So this is really how you have to, for example, look at WebAssembly code in the browser. So yeah, now I'm unfortunately running out of time, so I have to make this quickly. But what I wanted to show is how to use it in a more real-world example. And I created a demo application using the Mandelbrot fractal. And of course, when talking about mathematical stuff, you also have to add some LaTeX nice equations to this overall thing. So please bear with me, but yeah, I don't want to dive into that at all. But instead, I want to show you how actually this overall thing can be used in production environment. And if you would like to use Rust, and I would really recommend you to explore more about Rust when working with WebAssembly, because it's a very, very nice programming language for web developers who want to move towards native speed. Then you can write your own statements here for exports, and you can have a very easy binding to directly call a function out of Rust in the JavaScript code, because WASM bindgem provides you with all the library tools you need to directly embed Rust code into your app, and surpasses all the WebAssembly module instantiation and compilation in between. And that's very nice. And in the end, the benefit you really get is that you have very nice performance figures just for the overall code. So this is what I benchmarked with the Mandelbrot fractal, measuring that on a full HD code. Yeah. This is what it looks like, and especially if you look at Safari, you see you can really gain a lot of performance out of that, because the WebKit JavaScript engine isn't as good as using the WebAssembly code. So if you'd like to see how it's implemented, how it works, so this project features an JavaScript and a WASM implementation of the same code using Rust. And yeah, it's very nice if you'd like to check it out and to see how it actually works to implement that in your own application. So at the end, I want to thank you for watching. I was Konstantin. You can also find the slides here if you want to see all the code examples and see everything. I hope you enjoyed it. And what I should say, one last thing. We have a quiz at our stand here at the FlowTrader stand here at the Dev Days, and you can actually win VR glasses there. So come over to our booth, check it out, and I hope you participate. And thanks for watching, thanks for listening.